So we have a rod, like a railroad track, one piece here, and the length of it is 100 meters. And let's say made out of iron or steel. And the temperature in the morning, right now, what's the temperature? What was it this morning when you drove in? 72 degrees right now. And by 3 o'clock in the afternoon, we're going to hit, 88 degrees. How much that beam is going to expand, the length of it, how much longer it's going to be. The equation we're going to use is the change in the length equal alpha times the original length times the change in temperature in Kelvin. And what is alpha? Alpha is the coefficient of thermal expansion. This is somewhere around alpha. These are some numbers for alpha around the 20-degree temperature. There's alpha. For lead, it's 29 times 10 to the negative 6. Aluminum, 24 times 10 to the negative 6. Brass, 19 times 10 to the negative 6. Copper, 17 times 10 to the negative 6. Iron, 12 times 10 to the negative 6. Concrete, 12 times 10 to the negative 6. Window glass, 11 times 10 to the minus 6. Pyrex glass, 3.3 times 10 to the minus 6. And Cortez, which is 0.5 times 10 to the minus 6. Just some sample of them. So I made this one iron for this track, which means alpha for that, iron or steel, is 12 times 10 to the negative 6. See it? 12 times 10 to the minus 6. That's what alpha is. These are alpha. I call these beta. You'll see them later. Why I call them beta. Now, so in this example, how long or how much extra this is going to expand by? That's the change in the length. Is going to be alpha, which is 12 times 10 to the negative 6, times the original length, which is what? 100, times the change in temperature. Here's the good news. We taken the final temperature minus the initial temperature, but it has to be in Kelvin. Well, if I take the 72 Celsius, in Kelvin you add to it what? 273? So let's add 273 to it. What is that number? In Kelvin, 72 plus 273. 345. The other temperature is 88 in Celsius. In Kelvin, add to it T Kelvin equals T Celsius plus 273. So 88 plus the T 73. Here's the good news. If you take the difference between the two numbers, what is 88 minus 72? 16. What do you think the difference here is? Also 16. Because you've taken the change in temperature. So really the equation is supposed to be in Kelvin, but if you do it in Celsius, the change in temperature is still going to be correct. So times the 16 here. It says 0.0192. This 100 meter will expand approximately by 1.92 centimeters, almost 2 centimeters, from this morning to about 3 o'clock in the afternoon. Will be longer by 2 centimeters. Now the same one, we'll use the same track here. It's 72 degrees right now. But let's assume for some reason, I'm not sure why, tonight's temperature is going to be minus 12 degrees. Instead of expansion, what's going to happen to it? It's going to shrink. So the change in the length is the same track, the same length. The final temperature minus the initial, that's where the change in temperature. Final minus the initial is at 84 degrees. Negative. So instead of expanding, what's going to happen to it? It's going to shrink. That track will shrink now by what? .08 centimeters. That track now is going to shrink by 10.8 centimeters. About this much. That's not small. That's only 100 meters long. Shrunk by 10 centimeters. So if that's a support to hold the beam of your bridge there and shrinks, and now it's not hanging on the support beam, the whole bridge is going to collapse. We're going to compensate for that. A lot of these design you will see actually when you look at them. Let's say this is the bridge here. This is to support that bridge here, that piece. It's the column. Instead of having the piece sits like this, we're going to be in trouble because if it shrinks, that might fall off the edge. You'll see it longer, like this. Instead of having a hole and put, a bolt in it, that hole, if you're looking at it, instead of being like, it will look like this. And you put the bolt in the middle there. And this one can move back and forth inside that. So it can expand, contract. Bigger, smaller. Now, if you want to bend a piece of metal there, make it bend nicely, a lot of times what we do actually, just to show you, we take a piece of metal, instead of one piece, we make it, by the way, this is what most highways will look like. You've probably seen these as you drive over them. See the expansion? And this one goes back and in. You drive over 391, when you make that turn to go into 91 to go over 291, you'll see that metal. Looks like that. Farmers, when they have that water there coming through the desert to heat, they have that buckle there. That's for heat expansion and shrinking. So when it expands, it goes a little bit higher. Comes back cold weather, it goes lower. What we do actually to make sure that you bend something nicely is we make it out of two materials with different values. So it comes out like this. As you heat them, they can have the same temperature because of heat transfer. They will have the same temperature, but because they have different values for alpha, the inner one might bend, make it like expand less than the other one, and you see it bend on an angle like this, on arc, by using different material for that. What about area expansion? You take a sheet metal there. You have a water tank. You have a washer. When I say washer, like a circle here. But now we're talking about area expansion. You take a sheet metal like this, and let's say it's half a meter by a meter long. And let's say it's made out of, we'll use aluminum. And that's using that to cover like your shed, the roof of your shed there. In the morning when you get up, the temperature, especially with summertime, temperature might be about 60 degrees in the morning. By 3 o'clock in the afternoon, if we're having a hot weather, it might be 95 degrees Celsius. The whole sheet will get bigger. The length will get bigger. The width will get bigger. The entire sheet is bigger when you heat it. The equation for area expansion will be different. And the equation for that, it will look like the change in the area. It's going to be 2 times alpha times the initial area times the change in temperature. Again, this should be in Kelvin, change in temperature. But we found out really change in temperature in Kelvin or Celsius, the same thing. Aluminum here, alpha for aluminum from the chart I showed you earlier today, for aluminum alpha is 24 times 10 to the negative 6. And what's the original area here? Isn't that length times width? Length times width, 1 times a half, which is 0.5. And what is the change in temperature from 60 to 95? That's plus 35 degrees. That's a plus here, increase, not a drop here. It says actually the area changed by 0.00084 square meters, or 8.4 times 10 to the negative 4 square meters. That's how much the area changed by, got bigger by that much. Okay, the next question we have here, if you have a washer and you want to cut a hole in it, we didn't cut it, we're going to cut a hole in it there. The washer is still there. If you heat that, it's going to expand if you heat it. It's going to look like this, bigger. And the hole is bigger. The washer is still in it there. That piece still inside, we didn't take it out yet. Now, if we remove the inner disc, that little washer, remove the inner disc, then heat it, so it will look like this. So there's a hole in it, and you get that piece there, and now you heat that. So this will be a little bit bigger. And this will be a little bigger if you heat it. The question, which one is bigger? Is this one bigger if you leave it like this, or if you put the hole in it first, then heat them? What do you think? Which one is bigger? I'm talking about, when I say bigger, I'm talking about the full disc and the hole here, or right here? It's actually the same. Right, equal to each other. So if you remove that little disc from the inside and heat them to the same temperature, or leave it and heat them to the same temperature here, the expansion will be the same. The outer one will be the same. The hole on the inside will be the same as this. That piece will be the same as this. So this topic is called heating a hole there. Okay, what about if it's volume? Volume actually volume expansion. Let's say we have a shape that looks like this. That says a block here. We'll give it the value, I don't know, 5, 6, and 3. And let's say this is made out of, let's pick a value, we have a number 4. Concrete. This is a block of concrete. We want to test it. We want to make sure, does this withstand the heat? So we're going to torch this to 200 degrees Fahrenheit today. I'll even go more than 400 degrees Fahrenheit. Let's torch it. Need to convert that to Celsius and Kelvin. So right now is 62 degrees Fahrenheit. And I'm going to change it to 400 degrees Fahrenheit. Boy, I was giving you 60 degrees Celsius, 95 degrees Celsius. 60 degrees Celsius is really hot. That should have been Fahrenheit, right? That's okay. People think we live somewhere really warm. They don't know where we live here. From 62 degrees Fahrenheit to 400 degrees Fahrenheit. And it's made out of concrete. What is the change in the volume? Change in the volume, because we have 3 sides here, 3 alpha. 3 alpha times the original volume, V0, times the change in temperature. I'm going to convert these degrees from Fahrenheit to Celsius, then to Kelvin. So from Fahrenheit to Celsius, here's my equation. To get it in Celsius, we go 5 over 9, T Fahrenheit minus 32. So let's see, what's the temperature in Celsius here? For this one, T Celsius equals 5 over 9 times 62 minus 32. 30 times 5 divided by 9, approximately 16.7. And this one in Celsius, 5 over 9, 400 minus the 32. And that's 204.4. So the change in temperature in Celsius, which happens to be the same change in temperature in Kelvin, the answer is the same for them, is going to be 204.4 minus 16.7, 187.7. So what is the change in volume? Let's say this is feet. Three times. Let me find alpha for concrete. For concrete is 12 times 10 to the negative 6. The initial temperature volume, 3 times 6 times 5, 18 times 5, 90, times the change in temperature, which is what? 187.7. Which is 0.61 cubic feet. That volume will increase by 0.61 cubic feet. Increase by. Now let's make it more fun. People say you should never fill your car with gas in the morning all the way to the top, because if you fill the tank all the way to the top, once the temperature rises, it's going to expand the gasoline, it's going to start dripping. Well, let's see. We'll use the same logic, the same story. We have a flask made out of copper. Excuse me. So copper flask. Is actually filled, I'll give you a volume, with volume, has a volume here, equals 150 cubic centimeters. And is filled to the brim. That means to the top. Can't add any more. What should we put in it? Filled it with what? With, let me look at the chart here. What do we have for values? I have olive oil. Okay. Could be alcohol, water, mercury, or olive oil. We have the values for every one of them. We'll use olive oil. We know the number for it. I can use alcohol, I can use water or mercury. Now, if the temperature increases from what do we use? What do you want to use for value? From what to what? 20 degrees Celsius to 35 degrees Celsius. The question is, how much oil will spill? How much oil is going to spill? And that's it. dots. I got mess there. How much oil spills out? Well, we need to know the change in the volume of the oil, by how much the volume of the oil. Now, this is actually liquid. For liquid, we use beta instead of alpha. So instead of 3 times alpha times the initial volume times the change in temperature, which is fine, but for liquid, you don't have volume like length times width times height. We don't have that. So what we tend to use for that, we use what we call beta. And beta is equivalent to 3 alpha. When I showed you the table earlier today, I have some betas on the bottom written on it. This is what beta is. For ether is 1.51 times 10 to the minus 3. For alcohol is 1.01 10 to the minus 3. For gasoline, 0.95 10 to the minus 3. For olive oil, 0.68 10 to the minus 3. For water, 0.21 10 to the minus 3. Mercury, 0.18 10 to the minus 3. So if this is gasoline, I think we use olive oil here, that's 0.68 times 10 to the minus 3. That's what beta. Not 3 times that number. Beta is actually 3 times that alpha if that was lead. You know? So we're going to use that beta, 0.68 times 10 to the minus 3. Times the original volume. What was the original volume of that shape is? The volume is what? 150 times the change in temperature, which is from 20 to 35 is 15. That's the change in the volume of the oil. The olive oil. So what do we have? 0.68 e to the negative 3 times 150 times 15. The change in the volume is 1.53 cubic centimeter. It was in centimeter. Now wait a minute. The flask is made out of what? Copper. When you heat copper, what's going to happen? It's going to get bigger. So the flask is going to expand. Let's find the change of the volume of the flask here. If the flask changes more than this, I'm okay. If it's less than this, I'm going to lose some olive oil. So since it's made out of copper, it's now liquid here, I'm going to use 3 alpha times the initial volume times delta T. 3 times alpha. Alpha for the copper flask. Let's go back to that chart again. What is alpha for copper? For copper, alpha is 17 times 10 to the minus 6. 17 times 10 to the minus 6. Times the initial volume, which is what? 150. Times the change in temperature, which is 15. And this one is 0.115 cubic centimeters. That's the change in volume for the flask. So the flask, it did increase, but not by a lot. The oil increased by a lot more. So the oil spills, how much oil spills? Is going to be the 1.53 minus the 0.115, the change in the two volumes. which is 1.415 cubic centimeter. So you're going to lose that much oil. So your gas tank, normally when you fill it with gas, there's the tank. You don't fill it all the way to the top. So as the temperature rises, that gas is going to increase. You're still okay. But if it was filled all the way to the top and there's nowhere to go, we're going to have a problem. We're going to look at what is it made out of, the tank. Is it steel? Is it aluminum? What's the tank made out of it? Copper? And see how much the volume changes by, and see how much the volume of the gas changes by, and the difference is the gas that's going to leak. Okay. I'll stop here with this video. I need to get a candy bar, not to eat it, but I have